Welcome back. This is video 3 of module 3. Last time I talked a little bit about a cartographic process model, and it's about using a specific cartographic language to convey a message to a map reader. And the key is using a language that the reader can understand. So one of the components of that cartographic language is the symbology that you use. But before I can talk about the symbology, I need to talk about levels of measurement. And I'll cover this in more depth in the next module. But for now, just remember that there are 4 different types of levels of measurement. There's nominal. Nominal levels of measurement are like, let's say, things, items. They don't necessarily have numerical quantities associated with them. So think of things like apples, oranges, tomatoes, peppers, red, green. They don't have numbers associated with them. Ordinal are also things that don't have numbers associated with them, but they do have a relative value associated with them. So when you think of something like small, medium, large, that might be an ordinal level of measurement, where you can place medium somewhere between small and large, but you don't know how far it is from medium to small or how far it is from medium to large. So you can place them on a relative quantity scale, but you can't put numbers to it. These 2 types are generally considered what you might call qualitative data. Interval data are pieces of data that you can put numbers to. And so you can put them on some type of a line of presence of or absence of. So if you think of something like temperature in degrees Fahrenheit, you might have something at 20 degrees Fahrenheit and something else at 40 degrees Fahrenheit and something else at 80 degrees Fahrenheit. But you can't really say that 80 degrees Fahrenheit is twice as hot as 40 degrees Fahrenheit. So you can put them on a number line, but you can't really do multiplication and division. You can do addition and subtraction. Ratio is the type of measurement level where you can do the multiplication and division. And generally it means there is a 0. There is a value of 0 for whatever that measure is. So if you think of population, there is a 0 population. So if you have populations of 200 and 400, you know that 400 people is twice as many people as 200 people. So those are the 4 levels of measurement. Depending upon what type of data you have, what level of measurement was used, you're going to use different symbology approaches to make your map. This figure comes from your book, and what it's showing is a vector model. So we have points, lines, and polygons or areas, and it's showing the types of measurement, the level of measurement that the data have. So nominal, these are kind of categories. You can see that you can't really assign a symbol to a category of something that makes you understand how big that is or how large that is. So there are specific unique symbols associated with points, lines, and polygons for nominal data. Now if you move up a level of measurement and you go to ordinal measurements, then you know that, for example, a medium city is bigger than a small city, but you can't tell how much bigger the medium city is from the small city. Similarly, for line features, you can make lines that vary in thickness or in size, but you can't tell what the number is between those things. Soil permeability is another one. For polygons, you can imagine there might be low, medium, and high permeabilities, but you don't know the difference between low and medium or medium and high. Okay, interval and ratio data you can put the numbers to. You can do addition, subtraction, and maybe multiplication and division with those. So for point symbols, you can make symbols whose size reflects the size of the value. And so you can actually do this 2 different ways in the GIS that ArcGIS provides. You can make the symbol areas proportional to the number associated with them. Or there's also a perceptual size, which isn't equivalent to the areal size that you can apply to the symbols, so that a size might look twice as large if it has twice as much of the quantity you're measuring. For linear features, one of the common ways of symbolizing these with quantities associated is a thickness. So a thicker line in this case has a higher flow than a thinner line does. And for polygons or area features, you can see that again small values of the measure will get a certain color, larger values will get a larger color. Now you could make this a continuum of absence of that color and total presence or saturation of that color if you wanted to. In this case, what's happened is classification, where the person who's drawn this map has decided to break all of the values from 0 to 300 into 3 different groups, and this is called classification. I'll talk about that in another video. So the type of symbols you're going to use depend upon the level of measurement of the data that the symbol represents. There are a bunch of standard symbols that you use, and this is part of the cartographic language thing. So if you're going to use something that the map reader will understand, you should use symbols that mean something to a map reader. So here's an example that shows a school. So when you see this symbol on a map and you understand cartographic language, you're going to understand that that symbol represents a school. Similarly with things like campgrounds and picnic areas. So there are sets of standard symbols that you can use in your map that convey a meaning beyond the fact that it's just a point in space. These are some other standards for linear features, in this case highways and railroads, stream features, hydrologic features. So a lot of these symbols are standard, and if you use the standard symbols, it's going to convey better meaning than if you use a unique symbol that only you understand. One of the other things you need to consider with symbology is scale and generalization. So I showed this image earlier on when I was talking about the vector model, and what this is an aerial image, an aerial photograph of the area around Colfax, Washington. And in my vector model, I've chosen to represent the streams as line features, and I've chosen to represent Colfax as a polygon. So this is the city limits of Colfax, Washington. Now I may have, when I made the map, decided that I don't really care about what the city limits of Colfax are. I just care about the fact that there's a city in this general location, and so I might decide that I'm going to represent Colfax as a point. So depending upon the level of generalization that you want to use, you can use completely different types of symbols and types of features to represent those things. Just like with symbology and there being standard symbols, there are actually rules for generalization that help you understand what level of generalization, what type of symbology you should use, depending upon the scale and the message that your map is trying to send. So symbology is really an involved component of the map language, but the more you use standards, the more you learn what the standards mean, and the more you use symbology to convey the essence of the message that you're trying to send, the better off your map will be, and the more easily understood that map will be by your map reader. That was really quick fly through of symbology. Next time I'm going to talk a little bit about classification, and that's basically grouping these numeric measures into some subset of groups, so that instead of having possibly 1,000 different numbers in your symbology, you might just have 3 or 4 or 7 or some number of groups. And that's called classification. I'll talk about that in the next video.